So that was all the non-English language in this talk. Maybe I swear when I do live coding, we'll see, because I can swear in Russian. I'm not going to do it on stage. I will do it on stage probably, eventually. So I am the head of engineering at a small company called Archeologic. I have a brilliant team, and what we're doing there is we work a lot with WebGL and WebVR to create 3D and VR and AR applications in your browser to show you real spaces. That can be real estate, that can be offices, that can be furniture, whatever, right? We're also building this platform called 3D.io to help you build your own applications. So we started off with the software as a service in your browser. Now we have a platform with a bunch of APIs and components that you can use to build such implementations or build such applications more easily. Highly recommend checking that out. I'm based in Zurich, Switzerland. So I flew quite a way. Actually, I flew from Norway because of reasons, but let's not talk about that too much. I have a very typical German, serious LinkedIn picture. That does help to keep recruiters at bay, by the way. So if you get too many recruiter response or requests, then just put up a picture like that and they'll just back off, which is nice. I'm also a Google developer expert for web technologies. Started off as a Google web developer expert for Polymer. You can ask me Polymer questions. I might go like, so maybe don't ask me Polymer questions too much. I forgot more than I used to know, I think. I work with Mozilla every now and then as a volunteer. I do contribute to their code as well. Highly recommend joining that community. So if you see something that you want to have fixed in Mozilla projects, definitely help out. They're very friendly people. So today we're going to talk about three things. First things first, what are all these acronyms? It started with virtual reality, VR, and then we had AR, and then we had MR, and then we had XR, and probably someone else is going to come up with a new one. So let's see what these are real quick. And then we're going to talk about a little less interesting thing, but I think it's still important for you to convince your bosses to totally have to do this. I mean, totally, right? It's so 2016 to not do this, so in 2018 you definitely want to do some of this stuff. So I'm going to give you a few arguments on how to convince your boss to let you work on these kind of projects, or maybe get clients that want something like that. And then we're going to talk about the interesting thing, how to actually make it yourself. All right, so as I said, there are a few abbreviations, a few 2 to 3 letter combinations of things that probably might be valuable to explain. So let's have a look. So we have a kind of a spectrum, right? So we have the real world and then we have virtual worlds. So we are here. It's just the real world. None of me is fake. I'm actually really here with you today, and hopefully you also are here and I'm not having a hallucination, right? And then on the other end is full-on virtual reality. You are immersing yourself in a virtual world. You're not seeing any of the reality anymore. You might have, who here has used a virtual reality headset before? An Oculus or an HTC Vive or Google Cardboard or Gear VR or mixed reality headset. Okay. So those of you who haven't, if you put on one of these headsets, you're in the virtual world. You do not see people. It's like, I don't like you people. I'm just going to be, ha! Much better. I like you people, that's why I'm not having one on right now. Notice, I like you, of course. So these are kind of the extremes, right? We can be fully here where we are right now, or we can be fully gone. I mean, still physically here, but in our minds, we are in a completely different space. We are completely somewhere else. But then there's a lot in the middle, right? And typically, the official definition of mixed reality used to be that's where it kind of is in the middle. So you are having a virtual world, but it has things that look like they're real, but they're not real. Think of Magic Leap, think of HoloLens maybe. Basically, you would have virtual objects. We could stay here, we could talk about things, I could walk around, but maybe the screen behind me isn't actually real. But if I touched it, it would behave as if it would be real. So it would be trying to get together what happens in the real world together with what happens in the virtual world. So maybe I would have like a box here that is actually virtual, but I could kick it. That is mixed reality, or was mixed reality. There's an asterisk because Microsoft decided, hold my beer, we're going to completely mean something different with mixed reality. So Microsoft calls mixed reality what normally is either an augmented reality headset or a virtual reality headset. So a lot of Windows mixed reality headsets these days, except the HoloLens, are actually virtual reality headsets. That might change in the future. We'll probably see more augmented reality and mixed reality actually becoming mixed reality again with Microsoft, but so far it's a little fuzzy on the terms. And then we have augmented reality is kind of right now is here, but might as well move a little forward towards mixed reality. Because with most virtual augmented reality in the applications these days, what we are having is we have a virtual object. So I can say, like, I want a chair there on my phone, for instance. And then it looks, if I look through my phone, it looks perfectly as if there would be a chair. But if I then move it, let's say I move it into the wall, it would still appear, but it can't physically be there because there's a wall. So augmented reality right now does not take the reality much into account, except for the HoloLens. The HoloLens does scan the room and figures out where certain physical things are, so you can put windows to the wall and they stick there. So that's pretty cool. So Microsoft HoloLens is an actual mixed reality headset, whereas most of the other things that we have so far are more augmented reality headsets. Then there's also the term holographic computing or ambient computing, I think. That's basically mixed reality. It's just a marketing term from Magic Leap because they wanted to invent their own words. So that's kind of the spectrum that we are on here. And then there might be something that is more virtual than real, but there's nothing yet. So that's these terms. But then there's XR, extended reality, which usually is meant to encompass all of these. So when I talk about XR, I mean this works in virtual reality as much as it works in mixed reality or augmented reality. So this is kind of like, that's all the terms put together, nicely wrapped up. Some people say XR is then here, but I haven't seen any real-world implementation of that. So I would say XR, when people are talking about XR, what they mean is this. All right. Real quick, most importantly, a few people asked me the question, do you think AR is going to kill VR? Or is VR going to win? Or is VR going to be the thing that kills AR? Or something like that, some variation. Right? It's like the sentence, Yahachu no Yemagu. You can also say Yamagu no Nihachu, right? You just switch the terms. So VR, it's not really the same thing. It's different concepts. VR is like a teleporter. I'm here. I should be somewhere else, or I want to be somewhere else, so I put myself in a virtual world somewhere else. It takes me somewhere else. I could put on a VR headset and think I'm on a Smith Mountain, which in a t-shirt is usually a terrible idea, even in summer. So, cold. So yeah, I can teleport myself anywhere else if I wish, right? And then we have AR, which doesn't move me away from where I am. It just adds things on top of what I've got. I can't see certain things, so AR gives me an additional layer of information. It's like a lens. Imagine like X-ray vision, right? So if I sit in front of a car, I only see the car as I see it from the outside, but I can maybe then put on some AR glasses or maybe even actually a contact lens or an AR device, and it shows me, oh, let's peel away this part of the car and have a look at the engine. Let's see how all these things are connected together. Show me all the cables in this building. This kind of stuff. You can't do that with your natural senses, so augmented reality adds to your natural senses. So these two do not fight. Imagine you're going to work, and for some reason you're not in your regular city, you're somewhere else. You have to do a business trip to Singapore, or even better, somewhere in China where you don't even know the language, right? Or maybe, who here knows Mandarin? That's what I thought. Xie xie, which is thank you, as far as I'm aware. That's the only word. Thank you is like the phrase that I want to learn in as many languages as possible. Anyway, I'm digressing. So you're in Singapore, you have to go to the office, or in Shanghai, let's say. You have to go to the office, you have no idea how to get there, and there's no one who can help you because no one speaks your language or English. So you can then use an AR glass, for instance, that says, hey, go in that direction, take that metro line, get off that stop, switch to another platform, sit down here. But when I'm sitting in this metro line, maybe the AR glass says you're going to be here for half an hour. And so you're like, there's lots of advertisement that's really loud and shrill and very colorful, but in a language that I don't understand and in an alphabet that I can't read. And there's lots of people very loudly speaking to me in a language that I don't understand. What's going on here? So maybe you want to go and play a game or watch a movie or something, and then you just switch your device to a VR mode, and somehow it figures out how to shut off everything. And the only thing you see is you in a cinema with a movie on, or a series or whatever, the next Brooklyn Nine-Nine episode or whatever. I highly recommend Great British Bake Off, by the way. If you want to see people baking cakes and failing at it, that's like the best thing ever. So you're watching an episode of Great British Bake Off, but then your glasses eventually turn back on and say, like, you have to get off in the next subway station, and then they are back in AR mode. So maybe a more smooth transition between the two avoids that question to begin with, but basically they're not fighting for each other. They're actually complementing each other. They're different concepts. Okay. Okay, Martin, you can do this. I have to motivate myself for this. All right, so you want to do VR or AR or 3D stuff on the web at work, do you? Yes? Do you? Yes. Very good. II Captain is a... someone told me that we have T-shirts here. If the person with the T-shirts is... Who was shouting II Captain? Captain, my captain. That person gets a T-shirt. All right, moving on. Moving on. So you want to do AR or VR or 3D projects on the web, but you have to convince your boss, and maybe you have to find clients or customers for this. So what is in this? Is this really a thing? Well, let's have a look. So the first question normally is like, yeah, cool, that's all fun and games and looks very impressive, but is there any use for it? What can you actually do with this, right? Is this just like games and stuff, or maybe movies? Okay, but what else? What can I do? Like, what's the business here? And then it's like, well, look, it is already being used in healthcare. There's this story I heard recently that a company has built a VR experience for people with severe burns. So someone who has burned a lot of area of their skin, they have to regrow that skin or maybe transplant some skin, and when the skin regrows, it's a very painful process, and moving is very painful, and you have to do like physiotherapy, so you have to move yourself in a certain therapy scenario, very painful. Pain is not only an objective thing, it's also a subjective thing. It depends on how much you focus on the pain and how much you are putting yourself in the painful situation, and your brain can actually even remember pain, which makes pain even more painful. So basically what they're doing is they're putting patients in virtual reality, in virtual worlds where they are fine and they can move around, and they basically, well, move around. They experience a different space. They are no longer in hospital, you're now in a nice place. And it turns out, by measuring statistically, asking them how bad was the pain today during the therapy, it goes down dramatically, up to 25%. So therapy makes a lot of sense. Also, training doctors. You probably want to train doctors on virtual reality surgeon simulations so that they actually can conduct test surgery on virtual humans rather than real humans. So there's a bunch of cases here in healthcare already. There's also design and engineering. If you have to build a container ship, you probably want to see how certain parts respond to each other and how certain parts work together. And seeing that in front of you on a small screen is not necessarily the right thing. What is even better would be to carve it out. And that's also why still, like, I think it's polycarbonate these days, but it was wood. There were wooden models, full-size wooden models of cars when cars were designed, and are still there. They're still doing it. And the problem is that it doesn't quite look like the thing you designed. It's a piece of wood in the end, right? But with augmented reality, we can put things on top, and we can say like, so this is how we could cable these things together, or this is where we would have to put screws and stuff. So you can emulate and simulate these things. You can also use that for maintenance as well. So if I'm standing in front of a Boeing 737 engine, That's a really complicated piece of technology. And maybe I don't remember what all the things do, or maybe I remember them, but I'm not exactly sure how I'm supposed to treat them. There was a plane crash 30 years ago that happened because, so basically Boeing said, or actually it wasn't Boeing, it was McDonnell Douglas. McDonnell Douglas has this maintenance manual for planes. And it says, whenever you're doing engine service, you have to do the following thing. You have to first unscrew the engine with the pylon. So there's the wing, there's a pylon, and then the engine is attached to the pylon. So the pylon is the connecting piece between the engine and the wing. And how it was supposed to be serviced was, you would remove the engine and the pylon, move it away, and then remove the pylon to do the actual engine service. But that costs time and is extremely difficult to do. So they're like, you know what? We're just not gonna do that. We're just gonna unscrew it with the entire pylon, with the pylon still attached, and then when we reattach it, we're just gonna do it like with a forklift. Was absolutely not the intended procedure, but was like 50% faster and lots of times cheaper and easier to do. So they did this, and it went fine for a couple of years until a plane crashed, and they found out it's because of this difference in how they treat it. So eventually, like maintenance technicians actually forgot what was the official procedure, because why would you go back and read a book? But if you would be basically like unscrewing the thingy and then your glasses say like, wait, did you detach the pylon? If you're not detaching the pylon first, this causes structural damage and the plane might crash. You do think twice if you do that. Right? So even for maintenance, there's a use for design and engineering, not only for engineering or design of technical solutions, but also just generally designing experiences. This is a thing that you can do. Marketing, sales, you can show people rather than tell people. People like to be shown things. They enjoy that. It's also relatively cheap. So these are cardboards. They cost like $5 each. If you ship them from China, they cost $2. So that'll be $8 spent on marketing budget. Amazing, and people love it. So there we go. You can use it to demonstrate something that you want to sell. For instance, if you want to sell a really expensive apartment, having the person walk through that apartment virtually does help a lot more than seeing a video or a picture, because you can't really picture a room that easily, right? Education, you can take your classroom somewhere completely different. You can show them things that you literally can't show them in the real world because they happened 2,000 years ago. That's pretty cool. Or you can take them to a completely different biotop and show them like, hey, this is the coral reef, without having to actually spend money to get the class there. That's pretty amazing as well. Tourism and travel, you can show them places and spaces and experiences. Here, this lady is having a virtual helicopter ride. She's having a good time. That's pretty cool. You don't get these kind of reactions from videos these days, do you? Because it's the new normal, so this is the next step up. You can use it for arts and entertainment, so you can make games, of course, but you can also give people tools to create stuff that you can't do. Like, I mean, you can probably, maybe in your living room, create a volcano once, right? Here you can do it repeatedly, so you can get like, you can paint with fire, you can paint with music. You used to have to take drugs to be able to paint with music. So that's pretty cool, you don't have to do that anymore. So yeah, there's a bunch of use cases right there, and I would say, go home, manager person. There is use cases. We can make money off of this regarding the use cases. Okay, Martin, that's cool, but blah, blah, blah. Use cases, nice and fine. Are people actually doing this? Yes. Oh yeah, but then it's like super experimental companies that have no real business. No, that's not true. There is actually a market. So first things first, in 2016, that's 2 years ago, we sold approximately 100 million devices alone. So that's 82 million of these are cardboards, and then we have a bunch of the other devices. We have 2 million Gear VR sold, and then the rest is between Oculus and HTC, and Microsoft wasn't on the market back then. Something. So they're basically 100 million devices are on the market worldwide. In 2016, we are seeing growth numbers. So actually, I don't know how, I have no newer numbers. These are the latest numbers that have been published, but we know that the sales have picked up and the prices are falling. And normally when things are getting cheaper, more people buy. Who here does own some sort of VR device? Cool. Who here owns a phone? A smartphone? Okay. Well, then you have an AR-capable device. That's only the VR devices. So regarding companies, there are companies that are using this in manufacturing and design, and you know, they figured out, so Intel and Coca-Cola, they both figured out to improve performance or efficiency in their logistics chain by 15 to 45% by adding information, or making information available to their workers. This is mostly AR, this is not really VR, but when I say XR, you know, all of this basically comes together. So in the AR case, we have quite a bit of an impact on the bottom line, as manager people like to say. So because this saves money. And then obviously, all together, in 2016, the market was $550 million. And that is 2016. We know that it's a few billion already in 2017, and it's expected to rise to 30-something billion, I think, in 2018, 19, and until 2020. So the market is growing, which means people want to go in there, but they're not there yet. And guess what that means? If I want to have a software product, but I don't have it yet, I have to pay developers. We are developers. This is good. Okay? Good. Okay, wakey, wakey. Dobre utro. Good morning. We are through the boring part. Let's do some cool stuff. So real quick, before we actually go into some code, I just want to let you know that there is a misconception. WebXR or WebVR is actually not doing the rendering. It doesn't produce 3D graphics. For 3D graphics, you have to look for something else. That is WebGL. WebGL has been around since 2011, and that produces 3D graphics. And we can then send the 3D graphics that we created in JavaScript and HTML, we can send these to the headsets. So WebXR gives us access to the headsets, gives us access to the sensors from the headsets and the controllers that you might have, but it's not doing rendering itself. Okay? Good. Sweet. It does give us the native refresh rate. So you know, who here knows what request animation frame does? If you haven't heard of it, it basically runs with the refresh rate of the browser. So you're not doing more work than you should be doing. You're doing exactly as much as the browser can display or the computer can display. Normally that is capped to 100 times per second. 60 times per second. But for VR, we want 100 times or 120 times per second. So WebVR gives us its own version of request animation frame that runs with whatever the device can do. Cool. Browser support is looking pretty cool. Dun, dun, dun. That's not a mistake. That is true. Edge team does a great job implementing this. It works with really well with the mixed reality headsets. Doesn't work on the HoloLens as of now, but I started going like, give us a HoloLens and we fix it. Give us a HoloLens and we fix it. Give us a HoloLens and we fix it. And they're like, okay, fine. So we'll see. Maybe we get a headset and we can fix it. So this is a really easy starter program. Obviously. No, of course not. I mean, what the hell is this, right? Like, oh my God. So first things first, it's all JavaScript. Burp. We have to do like some canvas, WebGL, blah, 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 buffers, some, what the fuck is this? You know, blah, 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 blah. And then it says, Fragment Shader left out for brevity. And I'm like, nice. I wrote this code, so I'm like, yeah, I can't fit this in as well, so I just left it out. So yeah, I would say this is not good, right? So we want to do something else. So instead of what we just saw, we're going to use a library from Mozilla. It's called A-Frame. And I might have some time to show you what we're doing on top of it as well, because we are providing some stuff that makes life even easier. So let's go to the best website ever. Well, this isn't exciting. But it has a button. That's cool. The button does nothing. That's amazing. So here's the code for this amazing website. Just so that you see that I'm not bullshitting you, I'm going to be like, sup, y'all, nice weather in Kyiv, right? Because it's not. So yeah, I'm not trolling. This is an actual page, and we can actually do something. Now I load two libraries. Actually, let's not load the second library. I'm going to comment that out real quick because why not? Let's start fresh. So we have an A scene, and it turns out that A-frame, all the shit you saw earlier on, this source code example, draws a triangle. It draws one triangle. It's not very exciting, is it? I can do that with a few lines of CSS, and cool. So instead what it does is it gives you an abstraction that is more reasonable. So I want to create a virtual world. So I have a bit of space, and then I have a camera, which is my user basically looking at it. And then I have some objects I want to place there, and then I have to have some light that shines on them so that I see something on the camera. And basically this is the idea. So here we have a scene, which is our empty space. We need a camera and a light, but A-frame tries to make it as easy as possible for us to not make mistakes. So A-frame goes like, right, no camera, no light, I'm just going to put some default stuff in. So we already have a camera and a light, and that automatically does what we would expect it to do. And then I can add entities. Now an entity is an object that I want to put in my virtual world. It doesn't look like anything yet. I have to give it some shape and form and color. So basically I can say I add a component. And A-frame comes with a bunch of components that look like this. Geometry, for instance, this is a component that determines how this thing's going to look like. Now I can also specify like all the points and things and blah, or I can just use a geometry that it has built in, for instance a box. And then I have to position this. So the camera stands at 0, 0, 0, which means 0, the first 0 is now not to the left, not to the right. I know, don't turn your back on the audience, but deal with it. Not to the left, not to the right. Y means not up or down. And Z means how far out of the screen do I come. So positive values come towards you. Negative values go into the screen. So the camera by default stands at 0, 0, 0 and looks into the screen. Bye. So what I want to do is I want to move my box into the screen a bit. Not to the left, not to the right, not up or down. I'm just going to move it 2 meters. These are units. They mean whatever the hell you want them to mean. In most cases, these are meters. So 2 meters into the screen, the box is 1 by 1 meter by default. Let's have a look. OK. Hey, there's a box. But wait, if the camera is at 0, 0, 0, then why is the box below me? And also, did you see, A-frame gives us for free the possibility to look around and move around. That's nice. Thank you, A-frame. Oh, and on full screen capabilities. Thanks, A-frame. That's nice. But why is it below us? Well, the reason is that technically the player is at 0, 0, 0, but my eyes are not in my feet, unless I had a really freakish accident. So actually, A-frame doesn't, in this configuration, my computer doesn't know how tall I am. So A-frame just assumes like 1.60 m is a reasonable size. If you have a headset that actually gives you the position in space, like HTC Vive or Oculus Rift or Windows Mixed Reality headsets, you actually are as tall as you are in the real world, which is kind of cool. So I can move that up to 1.60 m. And then the box is on eye level. Now the box is not particularly exciting. Also, why does it change color? Well, I didn't tell A-frame anything about the color. So it goes like, I don't know, it doesn't have a color, I need a color, a box has a color, so I'm just going to add a random one, right? Let's get rid of that. And I'll show you how. We can do that in code, but what's even cooler are the developer tools that A-frame comes with. So if I press Control-Alt-I or Control-Option-I, I get the developer tools from A-frame. And the developer tools have a bunch of stuff. So first things first, everything that my scene contains is visible in here. So we have the box, we have the camera, and 2 lights. These lights and the camera have been automatically inserted because we need one, right? So if I press on this wonderful thing here, I get controls to change everything about this box. And I can go back and I can straight away see, aha, the box has moved up and quite far away. And then I can add components. And it gives me a list of all the components that A-Frame comes with by default. And one of them is the material component. Now it's white. That's not very exciting, so I'm going to change the color to something more nice, like this. And we can go back, and hey, there it is. That's quite nice. And I can even go in and say, you know what, I want to put that in code now that I have experimented around and I like what I got. So here we go. Oh, it does. Wow, OK, the new A-Frame version is a little broken here. That was not the best idea. That's going to get fixed. It's going to be fine. Doesn't hurt anyway. It's using default values nonetheless. So here we go. Now I haven't copied the position so that it returned to me. I can do that with all the components. So I can click on here. I can also change that it's a box. I can say, no, you know what? I want this to be a torus knot. And because this is a very useful shape. I can also rotate it. I can also scale it up. You know? I can also scale it in all different directions. So I can say like 3 by 3 by 3. So I don't have to use the visual tooling. I can also use the parameters directly. So here we have it, right? So we are relatively flexible, and that's pretty cool. And we can do even more interesting things. So what I can do, for instance, as well. Actually, I do that in code now, because that's going to be more interesting. So I can load 3D models that artists have created for me. And again, it's the same thing. I have an entity, I have a position, I'm going to move it slightly to a different space because it's a little larger. Actually, no, here we go. And I load a format that's called GLTF. It's like JPEG. What JPEG is for images, GLTF kinda is for 3D models. It's a relatively new format. It's a pretty cool format. It's optimized for web 3D models. So then I can say, hey, can you please load models damaged helmet for me, which is a model that I found in the sample models, and there it is. Cool. But now, like, loading models and stuff, that's nice and fine, and this one is actually pretty cool, really. Like, it has these shiny bits and oh. But I can also do more interactive things. Now I can also bind to event listeners and stuff, but I don't have that much time. So I'm just going to show you something where I always forget how the parameters are called, and it always goes wrong, but I'll try it nonetheless. So I can say animate the not the position, animate the rotation from where it is, which is 0, 0, 0, to 0, 360 degrees, 0, over the course of 5 seconds. Do not ease it. So I want this to linearly do, and I think repeat is indefinite. So repeat as often as you can, as often as the browser allows you. And then we have a rotating helmet. There's other things we can do as well. I mean, this way we can relatively quickly start experimenting and building a world. We also made this a little nicer for you all by adding this library here. So we can take this library that we provide. It's free, it's open source. You definitely want to have a look at it. And then what happens? There's a new button in the inspector. So you might not have seen it, but there's a new button here. Now what does this button do? Well, let's have a look. So it gives you a bunch of things. It gives you our furniture library. It gives you something that's called poly.google.com, and it has an avocado next to it, so it's definitely going to be good. And it has staff picks. So the poly library, poly is a tool, or Google Blocks and Google Tilt Brush, the thing that you saw where someone draws something. That's a way to create 3D models in virtual reality, and it's quite cool. And if the Wi-Fi doesn't fail me terribly, no it doesn't, then you get the actual model. The problem with these models is random people on the internet created them, so they're not all good. So for instance, this is super tiny. I mean, we are 1.60 meters tall, and this entire world is like, yeah, small. So we can scale this up and stuff, that's fine. If you want something that is to scale, what we can alternatively do is, you can give us a two-dimensional floor plan. So if you have a floor plan of your office or your building or your flat, then we can just drag and drop things in and out. And here we just, because it's public, we don't want to have your office publicly in this thing. So we give a few models that we created. For instance, actually, I wanted to show you this one. You probably recognize, oh shit, it tells on the name now. Because I'm like, you probably can tell which apartment this is. But it actually tells you right now in the name, and now the internet seems to have died, which is amazing. Okay, never mind. Cool. Thanks. The previous one loaded fine, this one does not. That's amazing. Let's see, do we have completely? Yes. No, actually we haven't lost internet completely. That's good. So I can scroll down a bit and I can grab a chair. Ah, okay, hi, there we are. I can also grab chairs and I can change things around and I can, you know, do good things. Oh, now it's actually, that's not what I wanted. I wanted to remove this here. And I can then go back and walk through, whoa, what the hell what am I looking at? Ah, I'm in the staircase. Which of the two flats is it? I think it's this one. And then we are standing in, yeah, in Big Bang Theory's apartment. So you can build stuff with this relatively easily. You can always use APIs with this. You don't have to do this kind of stuff. And we have a bunch of more cool APIs that are not as easy to demo. For instance, we can automatically furnish apartments and stuff. So, as I'm slowly but surely running out of time, that was the live coding. Thank you very much. Build stuff with it, have fun. Do we still have time for questions?
I guess we have time for maybe 2 questions.
Kruтой.
There is a microphone over there.
Microphone, dun dun dun.
Hello, thanks for the great speech. It was interesting and funny. What I wanted to ask is, as for now, we have a few major players on this market, like HoloLens and so on, but they have their own solutions. And do we have some estimation for maybe merging something into one to develop the market? Because as for now, they just sitting in their case each other and okay, we have this solution and the other ones have another solution. But if we can combine some standard, maybe the market will grow very fast. So maybe we have.
So is there going to be a standard across all different manufacturers? Is that a question? And the answer is yes. It's called WebXR. It's exactly what we saw. This, what I've just done. If you have a cardboard, you can use it. If you have a Daydream, you can use it. If you have a Gear VR, you can use it. If you have a HoloLens, let's not talk about the HoloLens. If you have a Windows Mixed Reality headset, you can use it. If you have an Oculus, you can use it. If you have a HTC Vive, you can use it. So it works on pretty much all devices. On HoloLens, it's a bug that it doesn't work. So WebXR works across everything because it's the web. So if you have a browser, it will eventually probably display something.
Thanks.
Welcome. T-shirt there. Give that man a T-shirt. Yes?
Hi, I have a health-related question. There's a talk on the street that using a VR more than half an hour can make you feel bad. Not to mention that diving into VR in public places can get you robbed. And if something yank you out from the VR, does it damage really the health?
Right, so does it damage your health and what are safety concerns? There are safety concerns regarding VR and AR, both actually have different safety concerns. So for instance, if you, my example with the public space where you're in virtual reality, what you could have is, you could have a system that basically detects if someone enters your personal space and then like switches back to AR and goes like, proximity alert. So it's really science fiction-y, but the entire idea was science fiction-y, really, because these kind of devices don't exist. Regarding health, I don't know how you grew up, but my parents told me don't, go too close to the TV. It's going to be bad for your eyes. I don't think putting a screen literally a few centimeters away from your eyes is going to be good for your eyes. So there is obviously the same safety warnings as for all sorts of display devices. It might damage your eyes because you're not having as many focusing interactions as you normally have in the real world. AR might be less problematic, but also it can get really scary when something happens, something bad happens to you. So people with like heart disease might suffer from that. So we as an industry are really, really early on. So we have not developed any standards for this kind of stuff yet, but everyone's looking into it really, really urgently because this is something that we need to resolve as an industry. And this can't just be one manufacturer, this has to be across all manufacturers. So the WebXR community is looking into these kind of things with all sorts of concepts, but I think in the end it's going to be more or less user responsibility as it is. Like when you play computer games, eventually the game is going to be like, would you like to take a break? Maybe it's time to take a break. Netflix does the same, right? Hey, are you still there? Are you still alive? Yeah? Cool. So we probably need something similar for web, so not for web, for VR and AR devices, but there's no such thing yet. But very good question. Get that man a t-shirt.
Here you go. Yeah, you can take it.
I wonder if people are now asking questions because of the t-shirts.
A t-shirt, сзади.
By the way, I have actually a question for you. Can I eat this?
Sure, but after the talk.
Damn it.
Okay, I think this is going to be the last one, okay, guys?
Yeah, thank you for your presentation. And I have the question, does A-Frame got something for interaction with the scene?
Yes. So first things first, we have seen already that it comes with like standard controls out of the box. You have the possibility to use your keyboard and mouse to move around. The default on the phone is to actually, it automatically starts tracking where you're holding your phone towards. So that's automatically there. And then it has interactions for what's called teleport, for instance. So I can point my controller, if I have a controller, I can point my controller somewhere, press a button, and then go to that space. So there's a lot of interaction possibilities. There's also the possibility to use what's called a raycaster. You're basically, that also works with cardboard actually. You're shooting a ray and the first object you hit you can interact with, which makes sense. So that's built in. Then there's tons of components that users have built. So for instance, you can use the leap motion, or you can use the Mio or Mayo or whatever it's called. It's this wristband kind of thing. So yeah, there's lots of possibilities to interact with the scene. You can also theoretically, hypothetically, just figure out where the user clicks on the canvas and then shoot a ray and then intersect that with the object and then have clickable things in the scene.